6.3. Number 1, which of these is not an integer? This is 6.3, number 1. Which of these is not an integer? Remember, an integer is a positive number, a negative number, or 0, and they have to be whole numbers. So number A, 7/10, that's 0.7. That is not a whole number, so A is not. B is 6.5. Again, that's a decimal. That is not a whole number, so that is not an integer. C is a negative whole number, so C is correct. And D is a mixed number that when you try and divide it, it becomes a decimal. That is not a whole number. So the only answer for number 1 is C. Number 2. I guess it would help if I turned my projector on, wouldn't it? Number 2, identify each number that is an integer, so you may have more than one. 9. 9 is a whole number, so 9 is an integer. 2.79 is a decimal. It's not a whole number, so it is not. 4 squared. Can we do the math part of this? What do you get when you get 4 squared? Is 16 a whole number? Yes, so 4 squared is considered an integer. Okay? Yes, ma'am. Yes. Yes, ma'am. Negative 1/3. If I divide this out, that becomes 0.3 repeating. Okay, that is not a whole number. 52/3. When I divide that out, it becomes 14 something. No. 122, 17 point something. Okay, so that is not a whole number. When you do the next one, 68/17, when you divide that, that becomes 4. That is an integer. Negative 10, that's a whole number. That's an integer. And then the square root of 144. Square root of 144 says what number times itself equals 144. We know that's 12. And so 12 is an integer, so therefore the square root of 144 is an integer. So we had 5 answers on number 2 that was considered integers. Okay. Question number 3. Write an integer to represent each of the following. 15 feet below sea level. Now, sea level is the baseline they're giving you as where you're starting. So if you're going below that, that needs to be a negative 15. 418 feet above the ground. In this sense, the ground is your baseline, so that's your 0. So if I'm going above, it's positive, so it's 418. Sam owes $45. That means he doesn't have it. He has to pay somebody $45 because he had to borrow that money. So he owes is a negative, so negative 45. On number 4, it says which of the following is true? Negative 16 and positive 16. If you look at a number line, if you think of a number line, negative 16 is over here and positive 16 is here. Those are not the same number, so this is not true. B says negative 29 is greater than 24. If I think again of a number line, down here's negative 24, over here's positive 29. 29, negative 24, did I switch that around? I'm sorry. That should be negative 29 and this should be 24. Sorry. Negative 29 is to the left, so we know that is less than a positive 24, so that statement is not true. We have negative 47 is less than negative 43. Again, if you think of a number line, here's your negative 43, here's negative 47. Negative 47 is to the left, so that means it is less. So C is a true statement. We're going to check D though. Negative 70 is less than negative 77. When you look at that statement, here's your negative 77, here's your negative 70. Is 70 to the left of 77? No, so that is not less. So C is your correct answer for number 4. Number 5 says which day had the highest temperature. All of these numbers were in the negatives, so I need the one closest to 0, and that would be Wednesday. Wednesday. Okay? Number 6, it says which integer is less than negative 12. Well, here's your negative 12. If you think of a number line, the one to the left is going to be less. So if I continue that, negative 13, which is D, is less than negative 12. Okay. Number 7, it says identify each true statement, so you may have more than one. The first one is negative 4 is less than negative 3. On a number line, it's to the left, so that is true. So you would circle that one. Negative 1 is greater than positive 2. That is not true. A negative can never be greater than a positive. Okay, so that is not true. Negative 10 is greater than negative 9. That is incorrect, because if you think of your number line, negative 10 is to the left of negative 9. So that is less, not greater. Now, the next 3 I really don't like, because we haven't really talked about dividing negative numbers, but how they wrote it, we could say 12 divided by 3 is 4, so we know this number now is negative 4 is greater than negative 5. Okay, that is a true statement, because negative 4 is to the right of negative 5. If you have 15 over 3, that would be dividing, so that would be negative 5 is less than negative 2. That is also a true statement, because negative 5 is to the left of negative 2 on a number line. The next one is negative 21 over 3 and negative 24 over 4. This becomes a negative 7, and this becomes negative 6. This is not correct, because negative 7 is less than negative 6. So the only true statements I had here was the negative 4 is less than 3. The negative 12 thirds is greater than negative 5. And negative 15 thirds is less than negative 2. Okay. 8. The absolute value of a number is the distance from 0. The distance from 0. Okay? Remember, when it asks for absolute value, it always comes out to be positive, unless what? There was only one time it's going to come out. When is that? That negative is outside of that absolute value. Okay? So as long as my negative is on the inside of my absolute value, it always is positive. The only exception is when your negative is outside. Everybody see the difference with it being outside versus inside? Then I have to do this first. So the absolute value of 4 is 4, and that negative just connects back. That's the only time it's going to come out to be a negative. Okay? Otherwise, it's always positive. Yes, you see my difference with it being on the outside right there? Okay? On number 9, the absolute value of 9 is 9. Absolute value of negative 18 is a positive 18. And the absolute value of 0 is 0. Okay? On number 10, ask which of the following is true. Absolute value of negative 10 becomes out to be a positive 10, so we know positive 10 is equal to positive 10. That's a true statement. B says absolute value of 5 is the same as the absolute value of negative 5. Well, we got to do the math. Absolute value of 5 is 5. What's the absolute value of negative 5? 5. So is 5 equal to 5? So that's a true statement. C says absolute value of 17 is negative 17. Well, the absolute value of 17 is positive 17. So is a positive 17 the same as negative 17? No. Okay, so right now, C is the only one that's not true. We want to check D. Says the absolute value of 12 is 12. Well, what's the absolute value of 12? 12. Is positive 12 equal to positive 12? Yes, so that was a true statement. So C is the one that is not true on 6-3. Okay, we're moving along to 6-4. On number 1, which expression is represented by the model below? I'm going to write this in words first, okay? You're going to make a fraction of your shaded over the total columns. And you're going to times that by the fraction of the shaded over total rows. Okay? So when you look at, I'm going to draw this really quickly. Alright, and they shaded this one pretty good all the way down, and then they made those funny lines going across, okay? Now, when I say shaded columns, do not worry about the lines that are going across my paper. Columns, remember, go up and down. So how many total columns do we have? We have 2 total columns. How many of those are totally shaded? It has to be, the whole column has to be shaded. So that was 1. So I have 1/2 of my column shaded. Does everybody see that? Then I'm going to times by the rows. Rows go across your paper. So how many totally shaded rows do I have? Complete rows. 1 out of a total how many? So does everybody see where I got the 1/2 and the 1/3? So that is my model. So my answer for that is B. Now I'm going to step further than what the paper asked. What would be my answer to this problem using my model? How many are double shaded? 1 out of a total how many individual squares? So does everybody understand if they ask the question, what is the answer according to this model? I would put 1/6 because there is only one square that is double shaded in both directions over the total number of squares. So everybody see that? Because they could ask that question as well. Okay? All right, question number 2. They took one large rectangle, and if you notice, the lines that they used were different. I'm going to use different colors just because my lines are a little harder to make thinner, okay? So the black lines were the bolder lines. Does everybody see that? Then my red line is that really thin line on your paper. Does everybody see the difference? Now, when you look, you need to start with the bigger area first. So when you look at the bold area, okay, only the bold, what section of that rectangle is shaded? Now, I'm just looking at the bold area. So if I'm just looking in the black areas, ignore this line here for a minute. It would be half. Does everybody see that? Because I'm only looking at the bold, so ignore those thin lines right now. So there's only half of that rectangle that is shaded, correct? Then if you notice, they broke it down into smaller sections and put these little funny squiggly lines, and I can't make them upside down, so I'm just drawing a squiggly line. Okay, so what they meant by that was I took the big rectangle now and I broke it down even smaller. What is each little individual section representing in the smaller parts? What is this one little section right here representing over the total rectangle? 1/2, not 1/2. 1/4, because do you not agree that I have 4 of those equal sections, the smaller ones? So I took the bigger section and I'm cutting it down, which means you're dividing, into smaller sections, which was 1/4. Okay? So that is your math problem on that one by the model. So that would be A. Now, based on the models, you're probably going to have one question, okay, dealing with a model probably. You might have 2, but most likely one question that shows a model, okay? Hopefully it's going to be more multiplying than dividing, but you may just have to guess, okay? But look at the big picture first. What did I break down into? And then did I break that area down into something smaller? Okay? It's harder to take a cookie and cut it into 8 pieces and then put them back together into 4 pieces. Would you agree? It's easier to cut it into 4 pieces and then go smaller rather than go smaller and then have to put it back together. Okay? All right. Number 3. It says Kayla is making an art project with 3/4 inch strips of fabric. She has a strip of fabric that is 4 inches long. How many pieces can she cut from her strip of fabric? Well, they gave us a ruler, and I'm going to try and copy that ruler really quickly. It won't be as detailed or nice as the one on the paper, but and they have those little marks in here. Okay, so she had 4 inches of material, and she only needs 3/4 of an inch to do a project. So because they're modeling, okay, I want to circle 3/4 of an inch. So would everybody agree that when this 1 inch, and I broke it down, these are all 1/4? Because there's 4 pieces to get to 1. So I'm going to circle 3 of them. Now I'm going to circle 3 more. Here's 1 piece, and I'm going to carry over here and get 2 and 3. So everybody see why I'm circling 3 right there? Because 1/4 plus 1/4 plus 1/4 gives me a total of 3/4, right? So I'm circling 3 sections all together. Now, how many total sections of 3/4 did I have? I had 5 of them. Okay? I had 5 complete sections, and I had a little piece left over, right? Okay. Can I complete a project with this little piece? No. So how many projects can she complete? And that would be 5. Okay? Just be careful leaning like that. Okay, so C is your answer for number 3. Number 4, okay, it shows you a little diagram of a cube there, and it said this is a hole. How many sides of that cube can you see? I can only see 3 of it. I don't know what the back looks like. I can assume, but I really don't know. Especially when I get to the bottom part, because it says look at the model. And now I have some shaded pieces and a blank piece, right? What expression represents the shaded area of the model shown? So in the first cube in my model, how many are shaded? 2 out of 3. Was the second cube shaded in the same way? Yes. So I'm going to take 2/3 and times it by 2 because I have 2 cubes that are shaded the same way. So in this case, then A is my answer. Okay? Any questions on models? All right. Scooting ahead to 6.5. 6.5 says exponent shows how many times a base, okay, is used as a factor. Now what they mean there is, if I said 5 cubed, 5 is my base number, and 3 is my exponent. So that means I'm going to take my base number and multiply it by the base, the same number, 3 times. So that would be 5 times 5 times 5. No, because 5 times 3 is not the same answer as 5 times 5 times 5. Okay, so there is a difference there. Because 5 times 3 would be 15, correct? Well, if I just do 5 times 5, that already gives me 25, so I'm much higher when I times by that third 5. Okay, 5 times 5 is 25, and then 25 times 5, okay, is 125. Okay, now, the other thing on that page, don't forget, when I say a perfect square, that means I'm multiplying the number 2 times. So if I said 4 squared, that means 4 times 4, and so 16 is my perfect square. Okay? So the outcome of a number multiplied by itself is your perfect square. Okay? We're in the hints and notes. Okay? Now, when you take the square root, okay, we're going to take the square root of 16. They're asking you what number times itself gives you 16. And so these two things are like working backwards of each other. Okay, but they mean the same thing. So now let's look at number 1. Number 1 says, which are true about 4 to the 5th power? Well, we know that 4 is your base, so that's one of the things I'm going to circle. We know 5 is the exponent, so that's another line we're going to write or circle on there. What does 4 to the 5th power mean in expanded form? 4 times 4 times 4. How many times am I going to do it? 5 times. So I would circle that one. Then I need to check my answer. So I'm going to actually multiply 4 times 4 times 4 times 4 times 4 on my calculator, get an answer, and I get 1,024. Now remember, on your calculators, you have a button that looks like X with the Y up here. You can use that button, okay? When you do, now you may not look at crystals, because that's the calculator you'll use for your SOL test. There's an XY button. You would put in your base number first. So you're going to put in 4, hit this XY button. Then you're going to follow with your exponent, which was 5. Hit enter, and you should come up with 1,024. Okay, so you may need to practice that real quick if you need to, okay? But you can use your calculator very quickly to come up with an answer, okay? Now, number 2, do what now? You put in the base number first. So if I'm looking at this fraction here, my base number is 4. So you're going to put in 4 in your calculator. Hit that XY button, because now you're telling that calculator I'm putting this in as an exponent, as exponents. So they assume that the first number is your base. So when you hit that button, the next number you're going to hit is your exponent, and that was our 5. Then when you hit enter or equals on your calculator, it'll give you your answer. Okay? Just try it again. Hit 4, then XY, and then 5, and then enter. Oh, do you have to hit shift? Now, question number 2 says Suzanne wrote the values of the powers of 5 that she knew. So you have to chart a 5 to the first, 5 to the second, 5 to the third, 5 to the fourth. It says, what is the value of 5 to the 6th? So on your calculator again, you're going to hit 5, XY, 6, hit enter, and you should get 15,625. That's what you got. Okay. And if not, if you forget, times it. 5 times 5, and you're going to do that 6 times. Okay? The only mistake you have is when you hit 5 times 5. Some of you will forget how many times you've hit 5. So if you do it that way, you may want to do it a couple of times to make sure you come up with the same answer. This was 1. So as soon as you put in the first 5, that's 1. Then times, when I put in the second 5, that's 2. So every time you hit 5, you're counting. Even the first one. Okay? Yeah. Alright. Number 3 says, which of the following is not a perfect square? Well, 49 is a perfect square of what number? 7. What is 32 a perfect square of? 6 would be what? 36. So nothing, because 5 is what? 25. So if you've already used 5 and know it's 25 and 6 is 36, there's no way I can get 32 in between those two without another number. Okay? So 32 is nothing. 81 is a perfect square of 9. And 121, 11. Okay? So B is my answer for number 3. Number 4, it says look at the pattern. So square 1 is made up of what? How many blocks? 4. Well, what am I going to multiply length times width to get 4? 2 times 2. Does everybody agree with that? Square 2, what's my size of my square? 3 by 3, and it gives me 9. So what's square 3 doing? 4 by 4, and it gives me 16. Now, what do you notice between my square number and the sides of my walls? I'm going up 1, right? So if they ask me for square 7, what 2 numbers do you think I'm going to multiply? 8 by 8, which is 64. Okay? Now, some of you may just want to finish that pattern until you get to square 7, and that's fine. We just saw the relationship that square number 2 was multiplying 3 by 3. And square 3 was multiplying 4 by 4. So we were just increasing that number 1 time. Do you understand it now? All right. That's what I want to get you to. Okay? So 64 is my answer for that one. 4. Number 5 says a pattern of decreasing perfect squares is shown below. So 121, I went to 100, went to 81, 64, and then I had a blank. So what number did I multiply together to give me 121? 11. And what about 100? And 81? And 64? 8. It's decreasing right there. They told me that. So what's the next one going to be? 7, which gives me 49. Now, is 49 my answer or is 7 my answer? Because the question says, what number do you need to square to find the missing term? 7 is your answer. Okay? 7 is your answer. Now, 49 would have fit in my blank. But they didn't say what number fills in the blank. They said, what number do you need to square to find the missing number? Okay? So I have to multiply 7 squared to give me 49. Okay? Now, number 6, they just basically wanted you to find the perfect square. So 0 squared is what? 0. 1 squared is 1 squared is 1, because that means 1 times 1. What's 2 squared? 3 squared? 9. 4 squared? 5 squared? 25. 6 squared? 7 squared? Okay, 8 squared? 64. 64. 9 squared? 81. 10 squared? 100, 11 squared, 12 squared, 13 squared, 14 squared, And 15 squared. 225, okay? Now, here's a trick question, and you may want to write this down. What is any number or letter to the 0 power? 1. Thank you, Molly. 1. Any number or letter to the 0 power is always 1. It's not 0, it's 1. Okay? And that's a trick question. Because we want to put 0, but it's not. It is 1. Do I now? For 0 squared, okay, but now pay attention, Riley. 0 squared, when I say anything to the 0 power, my 0 is my exponent. Now, on what you're talking about, you had 0 squared. 0 is my base. So you're correct on that one. That is 0. Because in our concept of, we actually have a 1 out here, okay? This one is really not, I don't have it. So that 1 is hidden, so it's always 1. Okay? It's just one of those mathematical hidden rules that you just gotta accept. Okay? You have something, but we don't know what it is. Okay? So it's just 1. Okay? Sometimes you can't. Sometimes they are. Sometimes they're so abstract, we gotta figure it out. Okay? Okay. Alright. 6.6. Alright. We're going to do these really quickly up until lunch, and then we're going to go. I'm going to try and go as quick as I can to make sure that you understand, though. On hints and notes up at the top. Okay, under the hints and notes. Up at the very top, you need to put change all mixed numbers to improper fractions. Before you can multiply or divide fractions, you have to change all mixed numbers to improper fractions. You have to. Then it says when multiplying fractions, you're going to multiply your two top numbers. You're going to multiply your two bottom numbers. And then back on your paper, it says remember to simplify. So you don't have to write anything else after that. Okay? You would get an incorrect answer. Okay? Because what we end up doing is when we don't change, if I have 1.5 pieces of something, and I say, okay, I'm going to double that, what happens is people will either multiply this by 2 or they'll multiply this by 2. And unfortunately, I have both pieces. So the reason I have to change it to improper is to make sure that I'm putting them as one group of numbers and I'm multiplying it to both at the same time. Okay? Now, you can do it as a mixed number, but what you have to do is you have to multiply this one by 2, then you have to multiply this one by 2, and then add it back together. And we forget to do that. Okay? So that's why we changed to improper first, so we don't forget. Okay? Now, when you divide fractions, which is still in the hints and notes, okay, you're going to copy the first fraction. So you're going to copy the first fraction. You're going to change your divide to multiply. And then you're going to take the reciprocal of the second fraction. Alright, now, number 1. It says, what is the product? The product means I'm multiplying. So we're going to take 2/3 and it tells me where the multiply goes, 5/6. So now this one, they're both fractions. I have no mixed number. I'm going to multiply my two tops. So 2 times 5 is 10. Multiply my bottom. 3 times 6 is 18. Now I need to reduce. I want to reduce this one by 2. So that means 10 divided by 2 is 5. 18 divided by 2 is 9. That cannot reduce down anymore. So 5/9 is my answer, which is A. Any even number can always be reduced by 2. Okay? Okay? Okay, number 2. What is the product of 1 and 1/3 and 7/10? First thing I've got to do is change this to improper. So 1 times 3 plus 1. So that's 4/3 times 7/10. Multiply your two top. Multiply the two bottom. And now reduce. They're both even, so let's reduce by 2. I become 14 now over 15. So that would be my answer. Question number 3. What is the product of 2 and 2/5 and 3 and 1/4? I've got to change both of these mixed numbers to improper. So this is 12 over 5 because it's 2 times 5 plus 2. So it's 12 over 5. 3 times 4 plus 1. So it gives me 13 over 4. I'm going to multiply. I get 156 over 20. If I need to change this mixed number back, I'm going to show you just very quickly. You can divide. That becomes, it'll go into it 7 times, which is 140. I'm going to subtract. Remember, this is my whole number. Okay? This is my numerator, which is the top number. This is my denominator, which is the bottom number. So this is 7 and 16 over 20. Now I'm going to reduce. I'm going to go basic. We're going to reduce by 2 because they're both even. I get 7 and 8 over 10. Again, they're even. I can reduce by 2 again and get 7 and 4 over 5. Okay? So that was number 3. And we're just going to stop there in time for lunch, okay? All right, we're picking right up with number 4. 4 says, what is the quotient? Quotient means I'm dividing. So I'm going to have 3/7 divided by 9/14. First fraction stays the same. I've got to rewrite the divide as a multiply, and I'm going to take the reciprocal of the second fraction. Now I'm going to multiply 3 times 14, 7 times 9. What I notice is both of these can be reduced by 7. So I get 6 over 9. And now what I realize is both of these can be reduced by 3. So at this point, this gives me 2/3 as my answer. Okay? That was number 4. Okay? Number 5, you have 2 and 3/4, and I'm dividing by 1/2. Got to change this to improper, so 2 times 4 plus 3. Now I need to rewrite it as a multiply. Multiply your two top. Multiply your two bottom. It's improper. Now I'm going to change it back to mixed and then reduce, and I get 5 and 1/2. Number 6, 3 1/8 divided by 1 1/4. Change both of these to mix, so 3 times 8 plus 1. 1 times 4 plus 1. Now I want to write the division as a multiply. Now multiply, I get 100 over 40. I can reduce if I want to. Both of these end in 10, so that actually becomes 10 over 4. I'm sorry, both of them end in 0. So now this is 2 2/4. And when I reduce, I get 2 1/2. Okay. On number 7, it says Kevin threw a football 19 2/3 yard. Scott threw it 24 1/3. Which statement is true? Well, when I start looking at my choices, it tells me who threw the football the farthest. Well, Scott threw the football the farthest. So I can eliminate A and C very quickly. Now I need to see how far he threw it. So I'm going to subtract the 2. Now, I do have a common denominator, but I cannot go 1 subtract 2. So at this point, I need to borrow from my 24. When I borrow from the 24, he comes down 1. And then I take this bottom number and add it to my top ones. So that becomes 3 plus 1, which is 4. Did everybody see what I did there? When I borrowed, the whole number went down 1. Which meant I took the bottom number and added it to the top 1 time. So 3 plus 1 is 4. Now 4 minus 2 is 2. And 23 minus 19 is 4. So my answer would be B. B. That was number 7. Number 8. The length of rope is 21 3/8 feet long. James cut a piece that was 2 3/4 feet long, and they want to know how much rope is left. Well, when I look here, I need to get a common denominator, so I'm going to write it again with no feet in there. For me to get a common denominator, I'm going to take this fraction and multiply by the opposite denominator, so that's 4. I'm going to take this fraction and multiply it by the opposite denominator, which is 8. So now I get a common denominator of 32. I cannot say 12 take away 24, so I have to borrow. This comes down 1, which means I take this bottom denominator and add it to the top. So this becomes 44 over 32. Now I'm going to subtract. I can reduce. If you want to do very basic, you can reduce by 2. I get 18 and 10 over 16. I can reduce by 2 again, and that gives me 5 over 8. So my answer would be 18 and 5/8. That was number 8. Now, number 9. Instead, the guy runs 5/8 of a mile every day for a week. So there's 7 days in a week, so I'm going to multiply it by 7. So that gives me 35 over 8 the first week that he ran. The second week is 1 1/3, and I want to multiply it by 7. Well, I have to change this to improper. So this is 4/3. Multiply my top, multiply my bottom. Now I want to know the total of the first week plus the second week, so I've got to add these. Well, for me to add them, I'm going to get a common denominator. So I'm going to multiply this fraction by 3. I'm going to multiply this fraction by the opposite denominator, which is 8. So now, 35 times 3 is 105. 28 times 8 is 224. When I add these together, I get 329. When I divide this out, I get 1. So I get 13 and 17/24 left. So, and it says about how far did he run. If you notice, this is not an exact answer. The one that's closest to that, about how much, is B, 15. Okay? May I have a question on 9? All right. 10. Maya is working on a project. It requires 3.5 yards of material. She has a total of 28 yards. How many projects can I complete? So we're going to divide. Got to make this a fraction. We're going to change this mixed number to improper. Rewrite it as a multiply. Now multiply top and bottom, then reduce, which this comes out to 8 total projects she can complete. Okay? Now 11's answer actually wasn't on there if you did this. We're going to add Friday's hours to Saturday's hours. 8, which was D. Okay. We're on 6, number 11, okay? 6, number 11. It was the word problem page. I wanted to know the total amount of time, so I've got to add these. For me to add, I've got to get a common denominator. So I'm going to take 3/4 and multiply by the opposite denominator, which is 2. I'm going to take 1/2 and multiply it by the opposite denominator, which is 4. So at this point now, I have 1 and 6. I'm sorry. Yep, 6/8 plus 3 and 4/8. I'm going to add, so I get 4 and 10/8. 10/8 is improper, so I need to pull out a set of 8. So when I pull out 8, that makes this increase 1, so that becomes 5 and 2/8. And when I reduce, I get 5 and 1/4. Now that answer was not on there. They have written 5 and 1/2 twice. Okay? As long as you showed me work, you're good. 12 is not on there. So we skip to 13. Derek's pancake recipe calls for 2 3/4 cup of milk. He wants to make 3 batches, so that means I'm going to multiply. Change to improper, so it's 11/4 times 3/1. Multiply your top, multiply your bottom. Change from improper back to mixed. So that would be 8 1/4, which is D. Number 14. Leslie has 4 bags of marbles. Each bag has 16 marbles. If 1/3 of the marbles were purple, how many purple marbles does Leslie have? Well, I've got to find out how many total marbles I have first, and I'm going to do that by taking 4 times 16, which gives me 64. If you have 1/3 of the 64 marbles, that tells me I'm going to be multiplying. So now I get 64/3 when I multiply my top and bottom. Now I'm going to get 21 1/3. So how many marbles could be purple? 21, because I can't have 1/3 of a marble. Okay? So 21 marbles is my answer. 15, Tom and Jimmy ran a race. Jimmy ran 2.5 miles, and Tom ran 2 1/4 times as much as Jimmy. So I've got to multiply, change everything to improper. So this is 5/2 times 9/4. Multiply your top, multiply your bottom. How many times will that go in? So it's 5 and 5/8, which is C. Okay? And 16, for each half a cup of milk, it has 4 grams of protein. Exactly how many grams are in 3.5 cups of milk? Well, I can figure out how many times a half a cup will go into 3.5 by dividing. So at this point, change to improper. Now rewrite it as a multiply problem. Multiply. In this case, divide. It comes out to a whole number. Now, so there's seven servings of milk I can get out of 3.5. So now I'm going to take the 7 and times it by my 4 grams. So that would be 28 grams of protein in that 3.5 cups of milk. So that would be D. Okay? D. I goes to 620. All right, 6.7, this is basically adding, subtracting, multiplying, and dividing decimals. So I want you to do 6.7 really quickly. It's 1 through 7.